Hello friends, my name is AJ and welcome to the first video of the new data structures series. In this video, I'm going to introduce the series and what it's about. I'm going to talk about the structure of the series as well as go over any of the basic prerequisites that you might need to know before jumping into it. All right, so without further ado, let's get started. Now, this new data structure series is going to talk about two of the fundamental and main concepts in computer science. And the first one that we're going to be talking about here is going to be data structures. And data structures is in the name of the course. Now, what is a data structure? Well, a data structure is a way or a structure by which we store and organize large amounts of data. Right? So data structure is a way we store and organize large amounts of data in our program. All right? And it's very important that we model data in a way that best fits the scenario that you're working on or the problem that you're trying to solve. And there are dozens of data structures out there, but learning which ones apply to which problems and also how to implement them is really important. Now, you might be wondering, why do we care about data structures? Why is this important? Well, I'm going to show you a few examples here of where data structures might actually be useful in order to model certain situations in our programs. Okay, so the first thing I'm going to talk about here is I'm going to draw out a road network, right? A road network. So let's say we have all these different points. Let's say we have a point here on our map, here, here, here. Let's say we have one here and here, right? And we also have roads that connect all these points. So let's say we have, a road connecting these points here. Let's say we have another road right over here. And we can just continue to fill in our diagram, right? So let's say we have a road here. We also have a road here. And let's say we have a road over here, right? And some of these are not very straight. So I'll try and make it straighter. Right? So let's say this is, a road network. And let's say we have a point here, let's say that this is point A and we want to go to some point B, right? And we want to try and find the fastest way to get from point A to point B, right? Well, how do we do that? The first thing we need to do is we need to represent our entire road network in our program, right? We have this very complicated looking diagram here. We have all these points, we have all these lines. How do we actually connect all these things and show it and basically represent it in our program? And this is a very common data structure that we're actually going to be talking about in a future lesson, all right? But this is just one example where knowing how we can structure this data in our code is extremely important to solve a certain problem. In this case, the shortest path from one point to another. Let's say that we look at even another scenario. Let's say we're trying to code a music player, right? Or an app that plays music. Right over here. Well, you often have your one song, right? This is usually you have a song right over here, and this is the song that you generally are listening to. But then you also have a next song, right? After your music is done playing, you often will have a next song. And oftentimes also, the song that you're currently listening to followed another song, right? You had a previous song right over here. So I can say that this is a previous song, right? And this led into the current song you're listening to. And oftentimes that previous song also had a previous song. And it's like a chain that goes like this, right? So what is the best way to model this type of structure in our code, right? How can we represent this music player or all of the music that we're listening to in this, in this linear structure? That's another data structure that we will be talking about. And it's important to learn, again, how we can represent these different situations in our code because there are so many useful cases for something like this or many useful applications for a structure like this. Now, let's say we also wanted to code something else. Let's say we wanted to code a file explorer, right? Like the file explorer on your computer. If you use Mac, you might use the Finder app. I believe that it's just probably Files or File Explorer on Windows as well. But when you have your files, you often have folders in your file system. And then within those folders, you have many files, or you may have even other folders, right? So let me draw this out. Let's say I have here a folder that looks like this right over here. Let's say I have this folder, right? This is a folder. And within that folder, I can have many things, right? I can have, for example, a document that looks just like this, right? I can have another document that looks just like this, but I might also have another folder inside of that folder. So I might have a folder that looks something like this, right? And this is another folder. Now within that folder, I can also have other documents, right? So I can have documents right here, and I can have documents right here, right? Now this is a very, very common hierarchical way of modeling our data. But how do we actually do this? Like, what structure do we use in our code? How do we implement this in our code? And that is another thing that we'll be talking about when it comes to data structures, finding the best data structures for these different problems, how to actually work with them and how to implement them and all of that. All right, so that is kind of the first main concept about data structures, and it's extremely important to know when working on programs or any app or anything that works with these unique structures or just a large amount of data in general. Now, the second concept that's extremely important is going to be the analysis of algorithms. So I'm going to write here the analysis of algorithms. Analysis of algorithms, right? And what this is basically referring to is, well, not all code, right, is created equal. You can have many algorithms that kind of do the exact same thing. You can write, you can write a solution to a certain problem in many different ways. However, not all of these solutions are the same, right? Some solutions are generally better than others, more efficient than others, right? So we need a way to tell, right, which algorithms, which algorithms are better than others, right? Are better than others. And really, when we're doing this, we're trying to decide which ones are more efficient than others, right? So which ones are generally more efficient than others. Now, why is this important, right? I mean, if you solve a problem in one way, I mean, that should work, right? I mean, if your solution works, it should work and there shouldn't be any problem, right? Why would anyone care about the efficiency of an algorithm? Well, it might not matter on a very small scale, but when you start to have large programs that handles a lot of data inputs, let's say millions and millions of data inputs, right? The efficiency of certain algorithms can actually be felt by the users, right? Either in the time that it takes for an operation to complete or the space that the algorithm uses and occupies on your device, right? So kind of making these algorithms more efficient and faster is often very integral to the user experience and designing good usable platforms. So we're going to be talking a lot about how to kind of, analyze an algorithm and how to tell which one is actually better than another or more efficient than another. And this is really important also when learning how to write good code, right? Approaching your problems in the most efficient way possible so that the program runs in the best way that it can, right? Now, throughout this course, there's going to be many lessons, and this might not necessarily be an exhaustive list. This is just what is planned now, and lessons might be subject to change. However, there's going to be many lessons from just basic coding concepts and review to talking about the different data structures that exist, how to implement them, what situations they can be used, how efficient using those data structures are. And we'll also talk a little bit about the analysis piece, the analysis of our algorithms, and kind of looking at both algorithms that we write and also algorithms that other people write. For example, with sorting, right? Taking a list and actually sorting it, which method of sorting is better than others. We'll be looking at all of that throughout the course of the lessons. All right. Now, in terms of actual basic prerequisites needed for this particular course, generally there's kind of two main components, and the first one is going to be the computer science fundamentals. Now, most of the concepts in this group should be covered by any entry-level computer science course, whether that is a college course, whether it is kind of an introductory online course, or if you're in high school, you took the AP Computer Science course or followed that. I actually have a entire YouTube series from a while ago talking about or going through all of the different concepts in the AP Computer Science course, and it was taught in Java. So if you are kind of stuck, or if you would like to refresh any of those concepts, definitely check that out. But mainly referring to kind of variables and, if statements and for loops and all of that, just loops in general, that is very important to know. These are just some of the more fundamental computer science concepts. And then another thing which is limited to, and a lot of courses teach this, especially if it's in a language like Java, is going to be object-oriented programming, right? Talking about the differences between classes and objects and how different objects can relate to each other depending on, inheritance and all of those type of things. Now, for data structures, this is really important because all of your data structures are objects, right? And so working with objects and working with these structures requires a good foundation and understanding of object-oriented programming concepts. Now, again, this is covered often, in an entry-level course. You do not need to know the advanced object-oriented programming concepts. Just kind of the basics will do. And again, I have a video series already on the AP Computer Science curriculum, and I believe that some of it, probably around unit 5 and 8, talk a lot about the object-oriented programming. So definitely check that out if you're a little bit unsure on either what I mean by that or, unsure on the concepts in general. And then lastly, a good thing to also know is just some basic, recursion and understanding of stack and heap. Now, you do not really need to know this at all. Even just kind of knowing the basics of recursion is fine. It will actually be going over kind of the basics of recursion again, so you don't really need to worry about, knowing too much on that front. And then for the languages, now this course, luckily, and this series in general, and even when you look online relating to data structure and all of that, because it's more of an abstract concept, it can apply to a lot of different programming languages, right? Whether you use something like Java or Python or something, on the iOS side like Swift, all of these languages can apply these concepts. Now, for the sake of this particular series, I will be working in Java. And the Java language is object-oriented, and it's very kind of a common way to introduce both object-oriented programming, but also introduce data structures. Now, if you do not know Java and you prefer to, follow along in a language like Python, you definitely can. Do note that a lot of the examples that I actually go over will be in Java. However, you can convert this over to Python pretty easily as long as you understand, again, some of the object-oriented programming concepts, which you can implement in Python. And so, feel free to use the language of your choice. Just know that a lot of the examples will be in Java, and you might need to kind of convert things over when you're actually practicing implementing some of the things that we go over. Now, for the actual IDE, I will be using IntelliJ. However, you are free to use any other IDE or program or code writing software that you wish, including Eclipse or anything else that you like. And now lastly, an optional thing is also just GitHub. I will be posting a lot of the code on GitHub, so if you need to, fork or clone any of those repositories, having GitHub is good. Also, just, if you prefer version control and, saving your code somewhere, GitHub is a great thing to know, but that's completely optional, and we won't really be covering GitHub in this particular series. All right. So now the last thing will be extra resources. Throughout the videos and the lessons, there will be extra resources, and I will actually put these in the description below a lot of times. And for example, there'll always be any of the code and the notes that I go over and write down in the video. They will all be posted to GitHub, so definitely feel free to check it out, or fork the repository or clone it or anything you need to do. And also sometimes if there are any external resources, like for example, if we're talking about, sorting a list and there's a really good, animation online, I might link that in the description below. So definitely check that out, if you are kind of interested and want to explore a little bit more deeply into the different subjects. Also, feel free to ask questions in the comment section below. I will definitely try to help answer them, but there will also be many people who are watching along who might have either similar questions or might also have answers to those questions. So it'll be a great way to kind of get engaged and to learn. All right, everyone, that is it for this lesson. If you liked it, feel free to like and subscribe for more content. In addition, I will be posting more on social media, so definitely check that out in the description below, and see you all in the next lesson.